Hello, this is Professor Campbell, and we're back. Today, we're going to be working on adding and subtracting rational expressions. And we're also going to be looking at how to find the LCD for rational expressions. All righty, let's get started. Okay, let's make some adjustments here. So I won't be in the Y. Here we go. All right, let's share our screen. Okay, adding, subtracting rational expressions. Now, fractions and rational expressions have a similarity in that you only combine the numerator and you do not combine the denominators. They stay the same. Now, I'm gonna mention it, but we're not gonna get into it right now. And you know, another thing when it comes to adding and subtracting fractions, the denominators have to be the same. So let's make some notation here, shall we? Let me get a different color. We're making some notations. Things to remember, okay? Denoms must be the same. Denominators must be the same. Only combine numerators. Only combine numerators. Now, because we're talking about rational expression, your your denominator may not just be a single number. Because we're looking at rational expressions, your denominator may not be a single number. It's going to be an expression because that's what we're talking about. So here again, because the first thing tells the denominator to stay the same, it doesn't matter what the denominator is, it will stay as is. Now, I'm saying that to say this. Let's look at a regular fraction first, where we just a fraction that we learned back in 3rd grade. That's 6/5 plus 2/5. It's a simple fraction. Now, if I'm telling you the denominator stays the same, my suggestion to you, because it's not going to change, just go ahead and write it in the answer section. That's one lesson you have to worry about. The denominator stays the same, so now let's just add the numerators. 6 plus 2 is 8, and we are done. Only combine numerator, and I did exactly what I just wrote. Now that's pretty simple. Now it's supposed to have something that looks like this. 9 over x plus 2. And that's going to be added to 3 over x plus 2. And I said this a couple seconds ago. It doesn't matter what the denominator is, because here again, we're dealing with rational expression, so it's going to be an expression. Your denominator is x plus 2. So go over to your answer and write x plus 2. Because that's one lesson we have to worry about. Now we're going to add our numerators, giving us a total of 12. And again, you cannot cancel anything because remember, in my previous lesson, I said that plus sign represents a stop sign. And when you see a stop sign in front of that number, you cannot cancel it with anything. Okay? Keep that in mind. Now, let's see if we look at another example of adding and subtracting rational expressions. Okay, here's one. We have 5m over 2n plus m over 2n. My suggestion is if you do not remember, I would write that invisible coefficient. When a variable stands alone, it has a coefficient understood to be 1. And the reason why I'm saying to write it, because some students will just combine and they not thinking that it's a 1m. If I have 5 m's and you have 1 m, we have 6 m's. But some students may not think like that, so I suggest you write that 1 there so you'll know that when adding, you do not combine the exponents. When adding, you do nothing with the exponent. Remember, these exponents are invisible 1. All you do is combine the coefficient and bring the variable over. Do not combine the exponents. And here again, the denominator does not change. It remains the same. Denominator does not change. It remains the same. All right, now let's change it a little bit and let's go to subtraction. Okay, let's see. We have 2y over 2y minus 7. And that's subtracted 7 over 2y minus 7. Now, I suggest, and I'm gonna tell you why I suggest it as we do another example. Because the denominator is not going to change, I would write one numerator. Write one numerator. So my first numerator is 2y, and there's a minus sign between them, and it's a 7 over there. So that's my tidbit. Write one numerator. It means, it means to put them together. Write one numerator. And that's what I did right there. I wrote one numerator. And once I've done that, I was like, oh, they're the same. I'm dividing the same expression by itself. So that gives me an answer of 1. And we're done. Now, are they all that simple? No, they're not. I see one that's going to be a little bit more funner. Don't worry, I make up words all the time. And my word is going to be, it's funner. And I think we're still recording, so we're doing good. Yes, we are. Okay. All right, let's look at one that has a little bit more going on. Okay. That's 3x squared plus 2x over x minus 1 minus 10x minus 5 over x minus 1. Now, let me write this in a different color. No need to factor. No need to factor. All right. We're going to do like it says up top. It says write one numerator. So my denominator is the same. So I know that's not going to change. I'm just going to write my denominator, x minus 1. I'm going to write my denominator together as 3x squared plus 2x. And I have 10x minus 5. What I normally do to make sure I understand the concept I'm going to share with you, my second part of my numerator, I wrote in parentheses because it's an expression. So here again, it helps you put things in perspective. Put second expression in parentheses. And this is why. If you recall, there's an imaginary number right here. There's an imaginary 1 right there. That is why I put my parentheses, because whenever there's a negative sign in front of parentheses, it's basically saying you are distributing that -1 to every number inside the parentheses. By putting the expression in parentheses, you can see that negative sign. This negative sign is this right here. That's that negative sign. And it simply means that you're multiplying -1 times the second expression. So let's make note of that. Negative sign indicates second expression is being multiplied by -1. It's being multiplied by -1 or distributed -1. Either way you say it, it's the same thing. So let's go ahead and make that magic happen, please. All right, let me recap before I go on. As I suggested earlier, I wrote one numerator. Here's a numerator from the first fraction. Here's a numerator from the second fraction. I only need to write the denominator twice because it's not going to change. The focus is on my numerator. When I wrote my second part of my numerator, I put it in parentheses, because if I didn't, it would tell me I had a -10. It simply means I'm multiplying the entire expression. Here again, I can't just change a 10 without changing the 5, because an expression is two numbers that are together. It's a quantity, not a quality. So by me putting them in parentheses, that keeps them together, allow me to see a -1 on the outside of the parentheses. And now it tells me I'm going to distribute or multiply the whole expression by -1. That means that signs inside the parentheses will change to their opposite. The signs of the terms in the parentheses will change to their opposite. Let's do it. Okay, so we have 3x squared plus 2x and we're going to distribute. We're going to distribute here, and we're going to distribute here. So that becomes a -10x, and it becomes a +5. Remember your rule for multiplying integers. Like signs are positive, unlike signs are negative. So once we distributed, this is what we have. Now we're going to combine like terms in the numerator. Combine like terms. Combine like terms. All right, let's see. So I see two terms that are alike. I have a 2x and a 10x. They're like terms because they have the same variable and or exponent. So 3x squared cannot be combined with anything. So that's going to say 3x squared. 2 minus 10 is 8. I teach when you're taking a big from a small, the answer is going to be negative plus 5. And my denominator stays the same. Now, at this point right here, you're not finished because it suggested, you notice I wrote up top not to cancel or factor anything. You cannot factor in the middle of a problem. But once you've gotten to the end, you want to factor to see if canceling is possible. Factor to see if canceling is possible. So that means we need to factor our numerator. And let's do it. Need some paper. All right, so let's, and here again, you have to brush up on your factoring skills. And I just love me because I just am so observant. 3 and 5 are prime. And here again, whenever there's a coefficient on the first term, that tends to be a challenge for some people. But if it's prime, OMG, it is too easy. Because it has two factors, one in itself. And there you go. Now I need an 8. So I need to, 5 is also prime, it has two factors. So I need to be able to put 5 in a spot. So when I check it, it's going to be able to get me 8 because I know 5 plus 3 is 8. I cannot put it here because that means when I do my outer, I'm going to say 5 times 3, which is going to be 15. It's way above where I need. So I'm going to have to put it right here. And of course, 5 times 1 is 5. I need these two to multiply, give me a 5x. These two are going to give me a 3x. When I multiply them together, oh, excuse me. When I add them together, I should get 8. And they're negative, so they're both going to be negative. And when I multiply, when I multiply -5 and -1, I'm going to positive 5, so I know I did it well. I was trying to get my middle term. And I did get my middle term. All right, so I now factored correctly. So this is my problem now. I have 3x minus 5 in parentheses and x minus 1 in parentheses. And my denominator, the x minus 1 is still hanging in there. Now I notice I can now cross cancel. This and this will cancel out, up and down or diagonal. So I'm left with 3x minus 5 as my answer. So we have just completed a problem where we're adding and subtracting rational expressions. Now you notice that particular problem is pretty tedious. Let's see if we can find one that even is a little bit more challenging, but not too much. And then we're going to go into finding the LCD. All right, let me just flip through here, see if I can find one. Okay. Okay, so I'm going to do one that's going to pose a challenge. I challenge my own self. Okay, let's see. Then I look at the answer like, ooh, oh, what are we doing there? Oh, that's right, let's see this. Okay. For a over a squared plus 2a minus 15 minus 12 over a squared plus 2a minus 15. Minus 15. Now, that looks kind of tricky, doesn't it? But what did we say earlier up in the lesson? If the denominator is the same, you can combine the numerators. The denominators are the same. Okay, it's a trinomial, but they are the same. So my next thing told you to write one denominator, a squared, plus 2a minus 15. Write one numerator. Now, notice I do not have to put a 12 in the parentheses because it is not an expression. I do not need to put 12 in the parentheses as in the previous problem because it's not an expression. And the notations basically said you put the second expression in parentheses. It is not. Now, we are not finished. We notice the denominators are the same, so we wrote the denominator and we combine our numerators. But our answer still looks like it has a lot going on. So at this point right here, now we want to factor to simplify. Factor to simplify. So you have to notice these things as you look at problems. So now we're going to factor to simplify. We're going to factor the numerator and we're going to factor the denominator. Looking at my numerator, I know both 4 and 12 have 4 in common. As a GCF, that's the biggest number that can divide into both of those. So I'm going to pull 4 out as my GCF, leaving me with A, and that's going to be 3. And as I check it, 4 times A is 4A, and 4 times 3 is 12. So I know I have factored correctly. My bottom number of my denominator is a trinomial, so it needs to be factored where I have 2 binomials. A squared can be factored into A and A. Now we need to factor 15, so its 2 factors can give me a sum of 2, or I can get a result of 2. And of course, the factor of 15 that give me a result of 2 is 5 and 3. 2 is positive, therefore I need my bigger number to be positive, and 3 is going to be minus. One of them has to be minus because my 15 is negative. Now, after close observation, I noticed that I have an A minus 3 on the bottom and I have an A minus 3 on the top. So therefore they can cancel out. What's left in my numerator? 4. What's in my denominator? A plus 5, and we're done. Adding and subtracting with like denominators. Adding and subtracting with like denominators. Now, it's not always going to be that fun and simple. Just like with fractions, you have fractions that have unlike denominators. You have to find the LCD before you can actually add or subtract. So adding, subtracting with unlike denominators. Okay, when I teach fractions like this, I have this problem here. I have 8/3 plus 2/5. Personally, I like to write my problem vertically so I can show students how I came about the equivalent fraction. So when I do problems like simple fractions, I rewrite my problem vertically. So it's 8/3 plus 2/5. As a plus. Okay, I noticed that the denominators are not the same. And here again, if you know multiples of the number, in other words, if you can count by the number, you can find the LCD. There's more than one way to skin cat, but this is the simplest way. If you count by 3s, 3, 6, 9, 12, 15, 18, 21. Now count by 5s, 5, 10, 15, 20, 25. What is the smallest number, least meaning smallest, what is the smallest number you said after listing both multiples that they had in common? Of course, the smallest number was 15. So that's an LCD for 3 and 15. Here again, that's the simplest way without going the long way as far as finding the LCM and all, finding the factor in the number and all that wonderful stuff. This is simple because the numbers are small. When the numbers are small, you can do it like I suggested, or you can also multiply the 2 denominators. When you multiply 3 times 5, it's going to give you 15. So that's when the fractions are simple. Either use the multiples of the number to find the LCD, which is the smallest they have in common, or you can multiply the 2. Now, we have just identified the LCD. You've identified, now we need to figure out how we got to it. Some instructors show it different ways. They say 15 divided by 5, which is 3. 15 divided by 3, which is 5. The way I like to show it is you ask yourself, here again, you have to be swift with those multiplication facts. What times 5 is going to give me 15, which is the same thing as saying 15 divided by 5 is 3. But the reason I do it my way, because you're making equivalent fractions. So if you ask yourself what times 5 gives you 3, you can see where the equivalence is going to come, because it's going to show you that 2/5 is going to be equal to the new fraction that you make. And because we're making equivalent fractions, whatever you multiply times the denominator, you also have to multiply times the numerator. That's how you get equivalent fractions. You have to multiply the numerator and the denominator by the same number. In the top fraction, you ask yourself, what times 3 gives you 15, or 15 divided by 3 gives you what? 5. Here again, we're making another equivalent fraction. I'm going to multiply the denominator by 5. I'm also going to multiply the numerator by 5. To make equivalent fraction, you have to multiply the numerator and the denominator by the same number. 8 times 5 is 40. 3 times 2 is 6. Now, our denominators are the same, and we can now combine the numerators. Of course, 40 plus 6 is 46. And our denominator stays the same as 15. Now, the point of doing that was to show you how we need to change the denominator to make them the same, and how I prefer the vertical method when it comes to adding or subtracting fractions with unlike denominators, because it will be fun. All right, that's using a regular fraction. Now let's look at where they're not the same. Let's throw some variables in there, shall we? All right, let's see. We have, the direction says we have 7 over 5x and 6 over 15x squared. That's a comma. You're not, right now we're just working on finding the LCD. We're not adding anything, we're just working on finding the LCD. Okay, first of all, let's look at the coefficients of both algebraic fractions. They both end in 5. That means they're both divisible by 5. Or you could count by 5s. You can count by 15s and see the smallest number they have in common. 5, 10, 15, 20, 25. Count by 15s, 15, 30, 45. So the LCD is going to be 5. I mean, excuse me, 15, my bad. 15. The LCD is going to be the smallest exponent. Oh, I got a brain for it. Variable, I think you said LCD. The variable LCD will be the largest exponent, because we can go from 5 to 15x if we multiply by 3x, and that gives us 15x squared. So our first kind of did was look at the coefficients. I said, what is the smallest number that both of those can go into? Smallest number that can both go into was 15. 5 goes into 15, and 15 goes into 15, so that's my LCD. My GCF, the greatest common factor. And then I want to know what my variable LCD would be, and I'm going to choose a variable with the largest exponent. In this case, it was 2, so that's my LCD. So 15x squared is my LCD. Okay, let's look at another one. And I might say it differently, but I never say the same thing the same way every time. Okay, all right. 5x squared over x minus. Okay, the question says to find the LCD for those two rational expressions. Now, I want you to pay attention closely and look at both denominators. One says x plus 2, the other one says x minus 2. Hear ye, he. Please take note. When denominators have nothing in common, that's the word denom, have nothing in common, you multiply to get the LCD in common. Multiply the 2 to get the LCD. Multiply the two denominators. To get the LCD. Okay, our denominators, we have our x plus 2 and x minus 2. They have nothing in common. So that means in order to write the LCD, I would simply multiply them together. So the LCD for those two expressions is x plus 2 and x minus 2. That would be my, if I was to add and subtract those two, that would be my LCD. So when they have nothing in common, you simply just write them as product. Here's another example. We have 8a and 5 plus, 5 over 8 plus 2. Here again, they have nothing in common, so that I can't write LCD the way I would need to. So my LCD would be made by multiplying a times a plus 2. Now, and it's as simple as that. Now I have done some pretty simple LCD, find the LCD. In our next lesson, we're going to get a little bit more involved, because then we're going to start actually putting them into problems where we're actually adding and subtracting after finding the LCD. So right now, I just wanted to show you that finding the LCD can be a little challenging in some cases. And then in other cases, it's pretty simple. But here again, it does get to the point where it's going to be a little more challenging than that. All right, I'm going to stop sharing my screen right now. And I just want to say it's been fun. And next lesson is going to be even more challenging. So right now, I just want you to have a good day. Enjoy, be safe, and I will see you again where we'll continue to rationalize expressions. You have a great one. This is Professor Campbell. See ya.